Are you here? She will come. So, topic is streamline flow. And when we are talking about the streamline flow, we will talk about the hydrodynamic. It means now fluid or water is moving. In this case, what do you mean by the steady flow of the fluid? So, Jordan, what is this steady flow?
So there is like no, how to say, change in the amount of water which passes out of the body. Like the flow of water is constant at all points for liquid.
Okay. So, in steady flow, what happens whenever fluid pass through a given point? Your velocity remain constant at that point. Velocity of every particle at this given point will be same. Example, if you have this tube, like we have this tube. In this case, example, you see, consider a point P here. So at this P point, you want you will see कि whatever molecule of water pass through this P point will have same velocity. That kind of fluid will be having the steady flow. Any doubt? What is steady flow, Jordan? So,
So,
whenever
uh,
there is a steady flow, the path taken by the fluid particle will be known as streamline path. Though in English we say whenever there is streamline work, it means very smooth work. Smooth work means it is happening perfectly. Here, almost the same thing. Ki perfect motion of the particle, the path taken by the fluid particle under the steady flow is the streamline path. Path taken by fluid under steady flow. Okay, is a streamline path. In this case,
so,
like yes, Jordan.
so in the definition, like you've given here, like at any given point, the velocity should be constant, but shouldn't the pressure and the temperature also be constant in order for the statement to be correct?
Yes, that we'll discuss in the coming topic
Okay,
in
sir.
detail how it like what are the different factors that affect this. The temperature should be same because if you increase the temperature, then there will be more turbulence, and more turbulence means there won't be steady or streamline flow. Okay. So whenever you talk about the streamline flow, you will see the curve. You have a specific tangent with the curve. It will give direction of the fluid. It's same like in electric field. When example, this is the electric field line. So curve at that point, and you have a tangent. What is the role of tangent in this case? Tangent will give direction. Same thing in case of streamline. Tangent of the curve will tell you the direction in which direction fluid is moving. Make sense, guys? Same like electric field. Next is equation of
Yes, sir. Can you
continuity.
go up, sir, 1 second?
Yeah, equation of continuity. So, Tuhina, I just explained ki we are talking about the hydrodynamic where fluid is moving. Hydrodynamic where fluid is
Yes,
moving.
sir.
So, in this case, when we talk about the steady flow, it means at a given point, example P in this diagram, whatever particle pass through the P
Yes, sir.
point will have same velocity, will have same velocity. And the
Yes, sir.
path uh, taken by the fluid under the steady flow is known as streamline path. Streamline path. And tangent at this point will give the direction of the movement. That's what I taught as of now.
So the Tangent gives the direction of what?
Example, this is the path. We are
No, sir,
talking
I
about
didn't
the
hear
path
you.
of the fluid. This is the path of the fluid. Okay. At a given point,
Yes, sir.
when you draw tangent, this blue color is the tangent drawn. So at
Yes,
given
sir.
point, if you draw tangent, tangent will give you direction of the fluid movement. Like what is the direction of the velocity?
Yes, sir. Yes, sir.
Understood?
Yes, sir. Done.
Next, equation of continuity, which say that it follow the law of conservation of mass. So this is really important. It follow the law of conservation of mass. Law of conservation of mass. One thing. And this is applicable only for the incompressible fluid. This is ideal situation. Actually, you always have compressible fluid. So when we say this is applicable for the incompressible fluid, what does it mean? In this situation, fluid have no impact of the wall. It is moving smoothly without any impact of wall. But in reality, we know fluid will hit the wall and there will be some difference. Remember, all this situation, what we are considering here is the ideal situation. And you know, ideal situation does not exist. So, equation of continuity will consider incompressible fluid and it will consider law of conservation of mass. If you apply these two, it this equation will tell us area and velocity multiplication will be constant. A V will be constant. A V will be constant. Okay. It means I'll draw a diagram. Example, if you take 3 point, huh, here you have one area, second area, third area. Okay, these are the 3 areas. Here, if you see, point is P, this is Q, and this is R. These are the 3 areas because area is different. Example here, area will be AP, here area will be AR, here area will be AQ, and velocity will be also different. VP, VR, VQ. We are saying their area and velocity multiplication remain constant. It means area of P and velocity of P will be equal to area of Q and velocity of Q and area of R velocity of R. It means this is the basic thing you have seen in your real life. Example, you have a pipe. Through this pipe, water is coming out. Okay? And you are watering the plant in your garden. If you compress the pipe, you are reducing area, but area and velocity multiplication remains same. In that situation, when you reduce area, your velocity will increase. It will come out with the high velocity. Make sense, guys? You all of you have seen this.
Yes, sir.
So can you
Like
repeat it again, sir?
I said, you have a pipe. This is the given pipe, smooth pipe. Here you have area of 1 centimeter square and velocity of 10 meter per second. I'm taking hypothetical situation. Now you press 80% of this area with your finger, only lower part is left. This is your finger. Okay. Now area will reduce to only 0.8 centimeter square. But you know, according to the equation of continuity, area in the first situation will be equal to area in the second situation. Area and velocity multiplication. First situation, area is 1 centimeter square. Velocity is 10 meter per second. Second area is zero point 0.2. You have to see, okay, after pressing your water pipe with the finger, what will be the impact on the velocity? Velocity will increase. If you do calculation, your V2 value will be equal to 50 meter per second. Correct. So when you are decreasing area, your velocity will increase. Make sense? First, there was only 10 and now 5 time increase. Why? Because your area is reducing 5 times. So in this case, you can say area is inversely proportional to the velocity. Area is inversely proportional to the velocity. Area is inversely proportional to the velocity. Any doubt?
No, sir.
So this is the equation of continuity and extremely important for your numerical purpose. You need to do ask a lot of questions from this, and this question are always easy. You never get difficult in this, and you will apply this in the Bernoulli's theorem also.
So that's what I wanted to ask, sir. The relation of Bernoulli's theorem to this.
We'll come to that. We'll apply the same equation over there.
Yes, sir.
So in this case, when you multiply area with the velocity, what you get is known as volume flux. There is a name for area into velocity is known as volume flux, or you can call it as flow rate. With what speed fluid is coming out. Okay. So if you increase area, then velocity will decrease. If you decrease area, velocity will increase. Got it? In case of steady flow, Chandana, should your speed high or low? When you're talking about steady flow, what do you think? To achieve the steady flow, do you should have low speed or high speed?
High speed.
Low speed. The slower is the speed, you can easily attain this. At high speed, there will be turbulence. Particle will move randomly in all the direction. Make sense?
Yes, sir.
So, steady flow is achieved usually at low speed. Okay. And in this steady flow, speed will be almost constant. It is like very slow. You can't even feel it is moving. I will show you this steady flow or laminar flow. You can't even feel this. See, I've shown you before.
पार्ट में घर्षण नहीं होता है, इस वजह से वो लिक्विड बिल्कुल सॉलिड नजर आता है। जो आप नॉर्मली देखते हो वो टर्बुलेंट फ्लो होता है, जहां लिक्विड आपको गिरता हुआ दिखता है। लेमिनार फ्लो ये आप घर के नल से भी जनरेट कर सकते हो। ये
You get, guys, you can't even feel it is moving. So it can happen in very slow rate. What we get in our houses, in our tap, is the turbulent flow because there is high speed. So you can see laminar.
सो यार मेरे पास एक बलून है जिसके अंदर मैं पानी फिल कर रहा हूँ अपनी किचन की टैप से, और कुछ ही देर बाद जब इसमें पानी भर जाता है मैं इसको गांठ मार देता हूँ इस बलून को, और इसके ऊपर जितना भी एक्स्ट्रा पानी है उसको एक कपड़े की मदद से हटा देता हूँ। क्यों? क्योंकि मुझे इस पे टेप चिपकानी है, और टेप तभी चिपकेगी जब इस पे से पानी हटेगा। फिर मैं कुछ इस पे बलून पे कुछ इस तरीके से टेप चिपका देता हूँ। अब मैं एक नाइफ की मदद से, चाकू की मदद से इसके अंदर होल करता हूँ। होल होने के बाद जो ये पानी का फ्लो आपको दिख रहा है, इसी पानी के फ्लो को फिजिक्स में हम लैमिनार फ्लो बोलते हैं।
This is not exactly laminar flow. This video is wrong.
So
because in laminar flow you can't even feel ki it is moving. Example you saw here. This is proper laminar flow.
इसमें बहते हुए लिक्विड के पार्टिकल्स में
Okay. See, You can't even feel it was moving. This is proper laminar flow. This video is fake. We should report this for the wrong information. So, steady flow means it is achieved at very low speed, and the speed beyond which steady flow will lose its property. Just give me a minute, guys. हेलो मेरे बच्चे, बहुत बढ़िया हो रहा है यहाँ पे।
Yes, sir.
हाँ, so steady flow, you saw it happened in a very slow speed, and there is a limit beyond which we will lose the steady flow and it will become turbulent. This speed at after which steady flow become turbulent is known as the critical speed. So Brinder, what is critical speed? Brinder, what is critical speed?
Sir, can I answer?
Yeah,
So it's like the maximum speed for steady flow to occur, after which it becomes turbulent.
yes. Brinder is there. Turbulent. This is the spelling of turbulent. Is this correct? Or E?
I don't know, sir.
It should be. I don't know. Even we don't care. How many of you are there?
So Tanvi has network issues. She tried joining, but she was not able to join. She told me.
Okay. I think she will join again. Brinder, are you there? Chandana?
Yes, sir.
Okay. That means I have to ask you two questions. Okay. So we have two type of main flow. One is steady flow before critical speed, and uh, turbulent flow after the critical speed. Example: if critical speed is 10 meter per second, before that, if you have 9 or 8, then it will be streamline flow. And if you have 11 or 15 or more than anything, that is turbulent flow. So this is the definition target key. If it is the speed, then you can call it as the steady flow. Got it? Steady flow is also described as a laminar flow. Okay. And this steady flow or laminar flow can be disturbed by using the what you can say, some object. Example: if you are having the fluid and moving with this speed in parallel to each other, and all no particle is intersecting each other, that's the beauty of streamline flow. Ki one particle path or one molecule path will not disturb the molecule path of other. That's why it is streamlined, right? If it is disturbing, then it will become turbulent flow. Correct. Now, so this is the proper streamline laminar flow or laminar flow, same thing. But example, you were having any particle in the different speed, one, two, three, four, five, six, like this. You keep any object in front of it. Example, you place any flat plate. So what will happen now? Particle will move in the different speed, like this, like this, like this, like this. So it will become turbulent. Then particle will mix with each other. Make sense? So this is turbulent flow. So using the streamline flow and placing the object in front of it can also affect the quality of the flow and it become turbulent. Any doubt, Jordan?
So
Chandana, any doubt?
No, sir.
If you don't have any doubt, you must be waiting for very popular topic. Which one is that, Jordan?
Bernoulli's theorem.
Exactly. So, come to the most popular topic of this chapter. And I think when you covered 11th class, not Jordan, you, because your 11th was pathetic.
Yes, I
Because
remember
of,
you taking this topic for me.
yes, because I know how pathetic it was. They didn't teach properly.
Yes, sir.
I don't consider your 11th class as 11th class, especially
So
physics.
at this point, I feel like I should redo 11th. I don't know how I passed.
Yeah, like your 11th was not proper 11th, especially for physics.
It was scary.
Especially for physics. So, Chandra, you must be knowing ki in your 11th class, first PU, Bernoulli theorem is one of the most popular topic from the physics.
Yes,
And
sir.
teacher must have told you ki it will 100% come in your exam,
Yes, sir.
right? So that's why people might forget this equation, but they never forget the Bernoulli's principle or Bernoulli's theorem. So in this case, remember, you use streamline flow only. You will use all the ideal situation, streamline flow, incompressible fluid, and all this stuff. And all these criteria is important because without criteria, your situation will completely change. Okay. So in this case, what will happen if you are using Bernoulli's theorem? Pressure, sum of the pressure plus kinetic energy per unit volume Reena, am I audible?
Sir, can you hear me?
Yes, you are having network issue.
Yes, sir, there was power cut here. I'm on
Okay.
mobile data right now.
Okay. So what did you miss from this topic?
Sir, a little more up.
Equation of continuity you missed.
Yes, sir, from there.
Okay. So equation of continuity tell us about if you take incompressible fluid and you follow the law of conservation of mass,
Yes,
then
sir.
your area into velocity will remain constant.
Yes, sir.
Example, if you take a pipe and pipe area is 1 centimeter square and velocity is 10 meter per second. If you put your finger in front of the tap, what will happen? Speed of the water will increase, right?
Yes, sir.
So why it is happening like this? Because it is following the equation of continuity, which says
Yes,
that
sir.
the area of one and velocity of one will be equal to area of two and velocity of two. Why? Because overall it remains constant. So if
Yes, sir.
area first area was one and speed 10, second area 0.2 and speed you have to calculate, it will become 5 times. We are not bothered about the numbers. It's just we are comparing the number and we are saying कि when you put your finger on this, your speed will increase 5 times.
Yes, sir, understood.
And this area into velocity is also known as volume flux or flow rate. Second is the steady flow, which we can study only at low speed because at very high speed it will become turbulent flow,
Yes, sir.
like randomly particle will hit the surface.
Yes, sir. Yes.
So in this case, we have a word critical speed, which says that a speed below which you will have streamline flow and above which you have turbulent flow. So this boundary is known as the critical speed.
Yes, sir.
Okay. And now we are doing one of the most popular topic of this 11th class physics. Like in 11th class, people who do first proper PU, I was doing uh, bitching kind of stuff with Jordan. He, your 11th class was pathetic, so I don't consider your 11th physics as physics covered. Otherwise, for
True,
any
sir.
norm for any normal student, everybody know कि Bernoulli's theorem is one of the most popular question. You can always expect Bernoulli theorem in your exam. Always.
Deepak sir, like Solanki sir
Solanki.
told us we should just
Hmm.
read NCRT for this.
No, if you read NCRT in physics, na, you can, but it's so boring that you don't want to read it. This. You should know what is the crux of the NCRT. If you read it NCRT, it's a wastage of time, I guess, in physics. Because in biology, you know every word is important. In physics, every word is not important. Conclusion of this paragraph is important for you. Come to the Bernoulli's theorem. Bernoulli's theorem is applicable for the streamline flow. And Bernoulli's theorem, like equation of continuity, is applicable for the incompressible fluid only. Remember, this incompressible fluid is ideal situation which we don't have. Okay, like fluid cannot compress. There is no impact of the wall on the fluid. It's just having its own nature. Practically not possible. It's like in every human being have freedom. They can do whatever they want to do. Do you think this is really applicable in our family? So Jordan is like, sir, don't hit my
Not
weak
saying
point.
anything. Not saying anything. You still haven't spoken to my dad, no, sir.
Yes, but I want to ask all of you. Tuhina, do you agree ki ideally we have freedom? We can do whatever we want to do because as a human being it's our choice. But do you really think you have full freedom? Unlimited, absolute freedom? Tuhina, Chandana, do you have absolute freedom in
No,
reality? Jordan have too much freedom.
Oh, yes, definitely.
Tuhina is trying to speak, I guess, but she can't. Again, network issue, I guess, because her mic is on.
It shows it's
Sir, can
off
you hear
here.
me?
Yes, I can hear.
It was muted for me though.
Okay. So tell me, do you have freedom? What example I gave you? Too much. Yes, sir. 100% agree. Right, Tuhina?
Yes, sir.
Yeah. So your pressure, kinetic energy per unit volume, and potential energy per unit volume. All these three things will be constant. That is your ultimate Bernoulli theorem. And why we are taking pressure? Actually, if you see work, then work per unit volume is pressure. So energy per unit volume is giving you everything. Okay, how? Because you know your work done is equal to pressure into volume. If you take work done per unit volume, what it will be like? PV by V cancel, it will be equal to. So we can say your work done per unit volume is equal to pressure. So it is like energy per unit volume remain constant. Energy per unit volume remain constant. Make sense, guys? How? Here you have to consider multiple things. You will take a tube that is above the uh, surface,
Sir,
Earth
little
surface.
bit up. Can you scroll?
Yeah. So
Yes.
if we are taking any tube here, we will consider potential energy also. And Jordan, tell me, what is the main cause of the potential energy?
So its position, so like wherever it's
Position,
positioned, the
configuration,
configuration, yeah.
correct? Position. So when you keep above the Earth surface, then there will be potential energy. That's why you should have some height if you want to consider your potential energy. It means, example, if you have the constant same height, then you don't need to consider. Correct? Example, if I take a tube like this, so you have this tube, and in this tube, we want to see how this works. So this is the thing. You have height here h1, and you have height here h2. Okay. So this is because of the configuration potential energy per unit volume you will use for. Then you have different area also. This is like area 1. This is area 2. Here at the starting point, you will have some pressure 1, and here you will have some pressure P2. Okay. And when particle is moving, then there will be kinetic energy. See, what is the main cause of particle energy? It is the difference in the pressure. The pressure with which particle is entering into the tube, and P2 is the pressure with which particle is coming out from the tube. Pressure difference unit. And last thing, the kinetic energy. When particle is moving, there will be some speed. Example, here you have V1 speed, here you have V2 speed. So different speed, different velocity. Because when area is different, you know velocity will be also different. Equation of continuity. Jordan, can you apply here equation of continuity?
You can.
Yes. So that's what we apply here. Equation of continuity, where we say ki if area is changing, as we can see, then volume will also change, because A1 V1 will be equal to A2 V2. So if area is different, different velocity, it means different kinetic energy. Okay. So here pressure will be P. Kinetic energy will be equal to, where should I write? Your kinetic energy will be equal to half rho V square, and here V is velocity, and potential energy per unit volume will be equal to rho gh. Chandana, why not mgh? Why not half mv square? It is half rho v square, where rho is density. Chandana,
So it is kinetic energy per volume.
per unit volume. So in kinetic energy, we have half mv square, you have mass. Mass by volume will be the density. Same, potential energy is mgh. Mgh, m divided by volume will be the density. That's why rho gh. Okay. So same thing you can write in this form. Heat pressure plus half rho v square plus rho gh is constant. Correct. So that is the ultimate thing you need to do. Using this, we can calculate the different energy. Example, if you want to see what is the change in the potential energy per unit volume, if you want to calculate potential energy per unit volume, how you will do? You know, mm, what is the potential energy value? Mgh, correct? This, your mass will be equal to density into volume, capital V, volume. Can I write as like this? Density G H into volume. Yes or no? So can you say your potential energy will be equal to density G? Your volume is changing, and because height is different, so H2 minus H1. Anybody have doubt? This is the change in the potential energy.
So,
Tuhina, what will be change in kinetic energy? Yes, Jordan.
but most of the questions they usually ask formulas related rho g hv. Like they'll ask us to equate one value to another value in terms of.
No, but in this case, height is different, na? So we have to consider this change in the potential energy.
Huh, because like when you're doing NMC questions last time, which I remember, they never gave us much of the height questions. They always made height was equal, but then the area was different for both.
In physics, you have to ignore NMC.
That is the
You get different type of question.
yes,
Many
sir.
question there are related to the height is same, but we should know if examiner is giving the different height, then you have to consider this. Otherwise, you will forget if you don't get questions. Correct. Same way, you know, our what is the issue? Our kinetic energy is half mv square. Half, instead of m, can we write there will be rho delta v, and velocity is different, so v2 square minus v1 square. Yes or no? Why we need to use this? We need to use this. Okay, we need to use this. And third thing, in case of work, if you do, so what will be the work? You know, P delta V. If pressure is different, then P1 minus P2 will be different. Third situation, tell me, any doubt? Correct? Understood?
Yes, sir. Just give me 1 minute, sir. Can you just scroll up? 1 minute. Yeah, that's much enough, sir.
Sure. Take your time, because not just for the explanation purpose, for numerical purpose, you have to sometimes calculate separately. What is your potential energy? What is your kinetic energy? What is your work done?
So delta K values you've written delta K into v, sorry, delta V into V2 square minus V1 square. So
Yes.
shouldn't
So
the
half
formula?
mv square. So v square have velocity difference. We already said velocity is different. That's why we are taking this.
So I mean, like instead of
Instead of
writing V
mass, you are using rho delta v.
rho delta. No, I mean the question was instead of writing delta V as well as this value, can't you just write V2 minus V1?
V2 minus V1 is explaining us velocity, and delta V is giving us volume. Both are the different things.
Okay, हाँ, okay, now I understood.
सर थोड़ा और स्लाइड अप कर सकते हो?
बिल्कुल कर सकते हैं, ये देखो. Take your time, because in this topic you will revise many things. U is equal to mgh, kinetic energy is equal to half mv square, work done is equal to p delta v. Every many formula you will use here. And as I always mention, remember this thing. Difficult the topic is, you will get easier question from system. Easier the topic is, you will get difficult question from such topic. This is the rule. I will show you the easiest question for of this topic in NEET. Done, guys.
Yes, sir.
Hmm. If all of you are done, let me know. Then we can solve further that you have to apply work energy theorem. work energy theorem. In this work energy theorem say that your work, total mechanical work, will be equal to your total kinetic energy, plus your total potential energy. This is the real formula. Okay, total work done is equal to change in kinetic energy plus potential energy, and this work done is basically your mechanical energy. Total mechanical energy is like kinetic energy and potential energy, your work energy power. Okay. So what is your work? Here your work is change in pressure multiply by change in volume, because you know work done is equal to pressure into volume. Okay. Kinetic energy, you have half mv square. So half, instead of mass, you have density into change in volume, V2 square minus V1 square, plus, if you see potential energy, mgh instead of mg. So m mass, you will have density into delta V g, and instead of h2 minus h1. So people try to remember the formula of Bernoulli's theorem, but you will see it is the simplest application of your work energy theorem. If you know simple work energy theorem, that your mechanical energy is equal to kinetic energy plus potential energy, and same formula. Correct. Again and again, you are using basic formula. Work is equal to power, pressure into the volume. Your kinetic energy is equal to half mv square. Your potential energy is equal to mgh. Your density is equal to mass by volume. You are using the basic formula. Understood? So if you understood this well, delta V is common in every situation. You can eliminate this, and you can take one side in one way, like initial form in initial side and final form in the final side. So initial form is pressure is P1. Initial kinetic energy will be half rho V1 square, and initial potential energy rho G H is equal to final pressure P2, final kinetic energy half rho V2 square, and final potential energy rho GH2. Make sense? Because for real application in your numerical, you will use mostly this thing. Imagine, Jordan, you said ki sir, height is same. If your h1 is equal to h2, you can eliminate both are same and opposite side, so it will cancel out. If this is the situation, then pressure 1 upon half rho V1 square will be equal to P2 half rho V2 square. Make sense?
Yes,
Based
sir.
on that, formula will change. But you should always know the real form. And the best real form you want to know in this is your mechanical energy. Then how to convert this mechanical energy to this form, kinetic energy in this form, and potential energy in this form. But everything else will be the special case of this. And that's the reason when you calculate all this stuff, you ultimately come to know your pressure plus kinetic energy per unit volume plus potential energy per unit volume will be constant. And we came up with the same thing what I taught you in the very beginning.
So can you just scroll up once? Yes, sir.
Barinder, can you hear properly?
Yes,
कभी कभी नेटवर्क इश्यू हो जाता है क्या तुम्हारे साथ?
नो सर, मैं क्लास में नहीं थी पहले तो। मैं कुछ काम कर रही थी।
वाह जी वाह, बट ऑफिशियली तो क्लास में थी, अनऑफिशियली नहीं थी, है?
यस, यस सर।
हाँ, ओके। So, in this session, we'll just do the application part of this Bernoulli theorem, and this topic will be. Just imagine कि in streamline flow, you have only this topic. You have equation of continuity. You have difference between the laminar flow and this turbulent flow. Bernoulli theorem and its application done. Wow, Sarah Anthony.
Good afternoon, sir. I'm sorry for joining late.
Good afternoon, Sarah, but you are very, very late. We
Yes,
covered many topics. Usually, for the small topic, I repeat it because it's beneficial for everyone. But we did so many things. So I'll try if after class I can make you quick revision for the whole topic, and then you can go through the video also.
yes, okay.
Everything is done, guys.
Yes, sir.
Even in this case, you can have different case. Like if your velocity is same or velocity is zero everywhere, either velocity is zero or v1 is equal to v2. So you can take same special case. It will be pressure 1 and rho gh1 will be equal to pressure 2 and rho gh2. Got it? So remember, it depends what is the special case, but your main formula will remain same in this situation. Okay. Even we are taking this incompressible fluid. In reality, when any fluid moves, some energy get lost due to the internal friction. Correct? Some energy gets lost due to the internal friction. And this fluid flow will lie between the different layers having different velocity. And frictional, this is the friction between the layer of the fluid is known as Tuhina. Friction in case of fluid is known as
Sir, I forgot.
viscosity.
Viscosity.
Yes, sir.
So this
Viscosity.
is the only part of the chapter I like. This whole Bernoulli's theorem and viscosity part.
But Bernoulli theorem was easy now. Everything was work energy power.
Yes, so
Nothing
that's
new
the only reason I like it, because it's easy.
because it's easy. So we'll discuss in the next topic, not in this session. But viscosity is basically friction in fluid, nothing else. Friction in fluids. That's all. Example: if you put a spoon in the glass and you keep rotating the water, you will see if you bring out your spoon after some time, this fluid will stop. What is the reason? This rotation motion will stop. Again, viscosity, right? This will be viscosity. Any doubt? And let's do last topic of this uh, today's class: application of Bernoulli's theorem. Chandana, what are the application of Bernoulli's theorem?
Sir, I don't remember.
Uh, Sarah, do you have any idea application of the Bernoulli's theorem?
No, sir.
Barinder, application of Bernoulli's theorem, because it is extremely important. So you have speed of efflux, Toricelli law. You have Venturi meter. It also explains how blood flow and it related to the heart attack. You know dynamic lift sometime in the extreme cyclone, roof of the uh, houses go off, it will fly off, and all the like swing of the ball, everything is because of the same law, application of Bernoulli's theorem. Sorry?
Swing of the what, sir?
Ball, cricket ball, or any kind of ball.
Yes, yes.
So this is because of the Bernoulli's theorem. So first is the speed of the efflux or Toricelli law, because this question is directly asked in your NEET. Why this pen is not working today? Just give me a minute.
So can you just share screen?
Yes, I think this pen was not working properly, so I'm just cleaning the screen. So first is the speed of the efflux. I hope now it will work. Yes. Speed of efflux. Speed of the efflux. And speed of efflux means when fluid come out from the container, what will be the speed? And this is explained by the Toricelli law. Toricelli law. What does it say? In this case, fluid will come from the some tank, and you want to see how it will fall. You have to apply your Bernoulli's theorem at different point. Example, first make a tank. Right. Okay. So this is the tank. In If you have this open tank, there will be the different height. Example, this height is Arre, this height is y1. This height is y2. Okay. Here you will have pressure P2, which will equal to upper pressure because there is some open space. There is some open space. Area will be A2. If you apply Bernoulli's theorem, remember pressure will be equal to atmospheric pressure. So atmospheric pressure plus half rho V1 square plus rho H is Y1 equal to total pressure P plus rho G Y2. Right? Because in this case, your initial velocity is 0. Container was at rest condition. Container in the initially having the water, and this water was not moving at all. That's why if you have rho V2 square, V2 value will be 0. Okay. V2 value will be 0. Second, your Y2 minus Y1 will be equal to H height because this H height is actually responsible for the movement. This H height is Y2 minus Y1. Give me 1 minute. Any doubt, guys? In this, because remember, only this H height is responsible for the movement of the fluid. And when this fluid come out of this with some velocity, this velocity will be V1. And we want to calculate this V1 value in this case. So if tank is open, then atmospheric pressure, total pressure will be the atmospheric pressure. So if tank open, then P2, which is equal to P, also equal to atmospheric pressure. So both the pressure will cancel out each other. And in this case, if you calculate speed, your speed will be equal to under root 2gh. Done. Okay. Second, if volume have some flow rate through the open hole, because this is open hole through which V1 is there. So your velocity will be 2gh, same thing. Area into velocity is constant. Area same. Velocity is equal to 2gh. Okay. So it just you want to calculate. Remember this thing properly. You want to calculate this speed. With what speed water will come out of the container? With what speed water will come out of the container? you can calculate using this Bernoulli theorem. Same, everything will be common. It depends what is the pressure given. If open tank pressure will be same, y2 minus y1 you can calculate is equal to gh, and based on that you can calculate your v1 value. How? Let me apply this also. See, if pressure is constant, pp cancel. If y1 go to another side, it will be rho g y2 minus y1. This whole part v2 is 0 will be equal to half rho v1 square. Rho will be cancelled. 2 will go to another side. Rho g h. No. Rho you can cancel y to right again and again. If you cancel rho and to another side, 2 g y2 minus y1 is equal to h v1 square. If you remove square, makes sense, guys? I am simply applying the same equation what is visible to you for knowledge theorem. Nothing. Because it is open tank, so your pressure will be equal to PA also. So both will cancel out each other. Tell me, based on this one knowledge theorem, it's easy. You should know what is constant, what will be eliminated. Formula you will never forget, because even if you forget, you can apply kinetic energy per unit volume, potential energy per unit volume, and work done per unit volume. Got it? So you can calculate what is the speed with which fluid will come out of the tank based on the height. You understood,
So,
or should I explain this again once more?
so one doubt, sir.
Yes, ask.
So they'll usually ask us to find like the distance from the tank when the water is spotted out from the hole.
Yes, you
How do
can
you cal
calculate distance as well.
how do you do
Example,
that?
this is the tank. Okay, in this tank there is hole, and it is coming out with some speed.
So don't we apply horizontal projectile formula?
Yes, we can apply here. So when fluid come out of this, it will fall like this. So this is the distance traveled. Let's take x. Here you have y1 value. You can calculate depend upon the like what is given. It will horizontal distance. Yes, you call it range, half of the range. For that also you need to calculate the uh, v1 speed.
So then there also like I just wanted to ask a question. So based on the position of the hole, sir, where can you get maximum X value? Is it towards the bottom of the tank or to that will be by bottom, no,
Speed,
sir?
speed, v1.
Not no X value of
X
X.
value of x will
Speed will be
be
greater lower, sir, because that means
exactly.
pressure as well as will be high at the bottom.
Yes.
After a point, if it's at the top, if after a point it stops flow, so that speed will be low. But then the X values, I was wondering where will it be maximum? Will it be at the middle or at the bottom?
See, in the middle you will get the value maximum even. Yeah, because you need to see what is the peak point. At lowest point you will have maximum velocity but
S-
not maximum range.
Range, yes, sir. That's all I wanted to know.
Yeah, depend on question what they will ask. We can calculate this distance traveled by this, because you have initial velocity, projectile motion, you have height, and based on that you can calculate x value. So, Toina, you told this already. Yes.
Yes, sir.
Next is Venturimeter. I think what is 12:36 now. We'll stop it here. Even I am tired, to be honest.
Yes, sir.
I am not teaching with the my maximum energy. So you okay. Huh. revise this topic properly. It will take maximum 1.5 hours to finish this, and I will do it today. I will also finish our Halvalkin Halvarins today. So
Yes, sir.
revise this properly. And
So when is next class?
next class, I will take at 6.
Yes, sir.
And I am giving task also for
So
this.
what will you teach in the next class?
I will finish this fluid as well as Halvalkin Halvarin. So I am giving all of you tasks.
So I'll be traveling again, so today it'll be little bit. I'll try finish as much as possible though.
Okay. And Sarah, for you, I will I can explain you if you want the remaining part.